All right, I trust you felt confident on your construction quiz. I trust you did well. And as we begin the second half of our lesson now, I want to wrap up some of these constructions together. Page 183 in your textbooks. Page 183 in your textbooks. And we want to look at some circle constructions now. Now, of all the constructions we've done, some of them I've said you need to think locus. You need to think of set of all possible points. Circle constructions especially, we need to be thinking loci. Look at page 183, that middle section, 3.35, where it says construction of circles. And let's take a look at exercise number 1. We want to construct a circle that passes through, that's a THR, through 2 given points and has its center on a given line. So what you want to do on your paper, first of all, is go ahead and pick a couple of points, any 2 random points, just pick up a couple. And then if you would, maybe, now draw a line. Don't draw the line so it goes between them. Don't draw the line so it runs parallel, but also don't make the line perpendicular. Okay, so maybe just a random slanty line, something like this, okay? So we want the circle to go through those 2 points, but we want the center to be on this line. Now think about it. For the circle to go through these 2 points, the center has to be equidistant from these points, doesn't it? Right? If the center's right here, then I can make the circle go through this point, but it's never going to go through that one. If the center's here, it'll go through this point, but it'll never reach that one. Instead, my center has to be equidistant from 2 given points. What is that locus? Yeah, the perpendicular bisector of the line segment that would join the points. Now, technically, you don't even have to draw this line segment necessarily, but we need that perpendicular bisector. So we're going to open the compass more than half that distance, make the arcs, and when we connect the dots, we realize anywhere along this perpendicular bisector, I could put the center of my circle, and I could open it to both points at the same time. But remember, the second part of this was the center had to be on this line. So really, this is where the center of my circle absolutely has to be. Now, I'm a little limited in chalkboard space here, but you would simply open your compass up to this point, which, by the way, should be the exact same as to that point, and you would make your circle, which, of course, as you see, I run out of room here, but that's how we would do construction number 1. Again, you've got to think locus. To get through the points, the center has to be equidistant from that perpendicular bisector. For the center to be on that given line, okay, wherever the line is. Which is why, by the way, you couldn't make the line run perpendicular to the line of these points, because then it would run parallel. You'd never get a circle. If it ran parallel, it'd just be too easy. It'd look too natural. So I wanted you to see with a little bit of an oblique nature there. Let's take a look at number 2. Same section, constructing a circle once again. This time, we are given that, if I can find where I put my book, we are given that our circle is supposed to touch a particular line at a particular point and have its center on some other line. So very similar to what we had last time, where the center's got to be on a particular line, but this time it touches another line. So go and draw yourself 2 lines. Again, make them oblique to each other. Make the lines oblique to each other. And let's see, do we want it to touch the first line? Let's mix it up a little bit. And let's say it's going to touch this line. And to pick a random point on the line, now let's go down to the bottom half here. No, I'm going to run out of chalkboard space. Let's pick up the top half. I ran out of chalkboard space last time. And it's going to touch at this point. Now think for a minute. If the line is going to touch at this point, touch isn't a very geometric word. That's not in your terms and definitions. But there's a word that means the same thing. Touch at a given point. Tangent. Yeah, I want my circle to be tangent right here. Does that make sense? But the center has got to be somewhere on this line. Could be anywhere. But in such a way that it touches or is tangent at that point. When we think tangent, we should think perpendicular, right? I know that wherever the center is, the radius to this line has got to be perpendicular. So what do you suppose I should construct? Yeah, how about a perpendicular? So let's construct a perpendicular at this point. Now I want the perpendicular to hit this line, because that's where, right about here is where my center is going to be. So open up the compass a little bit more, make those intersecting arcs. And if I put my center anywhere on this line, I could make the circle tangent to this line at this point. But for the center to be on this line, it specifically has to be here. Now the only requirement is, I said draw your two lines oblique to each other. The only key is this line couldn't be perpendicular to the other one. Otherwise you'd never get a circle that could fit the criteria. But otherwise, you simply measure out to this point, and to the best of your ability, hey, I think it's going to fit, yes. And we get our circle, tangent to the one line and center on the other. All right, let's take a look at number 3. Again, constructing another circle. And this time, you're given the radius of the circle. So, make a line maybe about 1 inch or so long, maybe 1.5 inches. Call it your radius. And this circle has to go through 2 given points. Now, understand this. If you have a given point here and a given point here, no circle with that radius can hit both of them. So the furthest these points can be is twice the radius, right? So the furthest away the point can be is here. So, make the 2 points, closer than that. So that way, they're within 2 radii distance of each other. So the circle's going to have that radius, and it's going to go through here and through here. Well, let's just think. For a circle to pass through this point and have this radius, then the center has to be this far away from that point, right? So if the center were here, I could have just going through, correct? But it wouldn't go through that one. But the locus, the first locus is, it just has to have this distance away. Well, as long as it's this distance, this distance, this distance, wait, you mean this given distance from this given point? Yeah. So what should I draw? It's not the answer yet. It's not the actual locus circle. But you realize, if I were to draw, or construct rather, a circle around this point with this radius, anywhere I put the point of my compass, I can make a circle go through this point, right? But that doesn't take care of this point. What do you suppose we do? Yeah, the same thing again. Because you realize, if I can finish the whole circle here, you realize anywhere along here, I could put the point of the compass, and it would go through this point, right? But I want to find a point where I could put the compass, and it would go through both of these. Hopefully you see it already. Either here or here. It doesn't matter. Because do you see that these 2 points are exactly this distance away? This is one way to do it. Then, of course, you simply measure out. You're already there, actually. And it does fit. And you've got your circle that passes through 2 given points, and it has exactly this radius. Now, there is another way you could do it. Because remember, for the circle to pass through both points, think back to our first construction, you would have to have the perpendicular bisector, right? And then you simply measure from either point this radius length away, and you found a point you could use. So there's 2 ways to do it. Either start with the perpendicular bisector, measure the radius, mark it off, or make 2 big circles with that radius, or depending on the size of your radius, you have a small radius, it'll be small circles. But you make a couple of circles going around each of the points, and wherever their arcs intersect with that radius distance is where the center should go. And there's 2 possibilities. I happen to pick the lower one, and there we go. There's our circle. This being the actual constructed circle in question. This was the circle they were asking for because it passes through these points and it has that given radius. All right, so that's a couple ways in which we could have done construction number 3. Let's take a look finally at construction number 6, and we'll be done for today. Let's take a look at construction number 6, and we'll be done for today. In construction number 6, this time, the circle we're asked to construct is going to touch, what's a better word there? Yeah, be tangent to 2 parallel lines. Now, if it's computer generated, you can make parallel lines really easily. If you're using lined paper, which I believe you probably are, you can also get parallel lines really easily. Unfortunately, I don't have ruled paper. Well, technically I do if I pulled down my graph grid, right? I could make some parallels, but I'm gonna do it the right way here, the construction way, and I'm gonna go ahead and make a transversal here. And I'm gonna just pick, let's just say this point here, and I'm going to make an arc. Oop, too big. Let's try that again. I'm gonna make an arc. Make an arc, measure across. We're going to little arc because the big arc didn't fit, and measure across. And this way we've got our 2 parallel lines. Now again, on a quiz or test, these parallels would be given to you. You wouldn't have to construct them, but it gave us a good opportunity to review how to construct parallels. Okay, so we've got our parallels here. And we were supposed to find how to construct a circle that would be tangent to both of these and would pass through some random given point. So picture this, a circle, first of all, that's tangent to both of them. Well, then the diameter of the circle would have to equal this distance, right? The radius would have to be half the distance. So the center would have to be somewhere along, oh yeah, equidistant to 2 parallel lines, a third straight line parallel to the given lines midway between them. So the first thing we need to do is construct a parallel. Now, the easiest way to do this, because you don't just want any parallel, you want the midway parallel, would be pick any point. I still have a residual point here. Make a perpendicular. By the way, what this will give you is the exact distance between the lines, correct? So I know that these lines are exactly that far apart. That's the distance between them. And then open the compass more than half of that. Arcs on either side. Go to the top. Arcs on either side. And this locus here gives me where my center could be. If I put the circle anywhere on here and measure this distance, I could make a circle that's tangent to both. But that's only the first criteria. The second criteria is my circle has to pass through some given point. Now the point can't be outside the lines. And if the point's on the lines, that kind of defeats the purpose. So let's pick a random point maybe here. My circle not only has to be tangent to these, but has to go through that point. Well, obviously, a circle right here wouldn't hit that point. Well, I do know the radius of my circle has to be exactly this much, right? That's going to be the radius. So you mean the radius has to be able to reach this? Yeah, the radius has to be able to reach that. So my center apparently needs to be right here. Or the center could be over there. I'm going to pick this point because it's more centrally located and I won't have to extend my lines, because I am lazy. But yeah, you just measure the you measure the distance from, you measure the radius distance from that point, and now when you draw your circle, whoop, compass slipped, we get our circle that is tangent to both lines and passes through the given point. Again, the construction is a little easier if you already have the parallels, but otherwise I think the construction is pretty easily seen. All right, your homework for this evening is to begin studying for your test in 2 more lessons. Begin studying for your test in 2 more lessons. A couple things to study to focus your study time on. Constructions 9 to 14b. Make sure you know how to do the memorized constructions we worked on. Bisecting the arc, making a parallel, dividing a line into any number of equal segments. circumscribing a circle, inscribing a circle, constructing a tangent at a point, constructing two tangents from a point. Know those. You do not need constructions 15 or 16. Also, theorems 47 and 52, your memorized loci. Make sure you know your memorized fundamental loci so that you're ready with those for the test. Intersecting loci, well, you can do those if you know your basics. These kind of constructions, well, you can do these if you know your loci and you know your basics. So memorize those things, work on those in 2 more lessons. We will have our test. We'll be reviewing in our next lesson. Have a wonderful rest of your day.